So all we do when we evaluate is find out what the answer is. And they always tell us what x equals when we have to evaluate. So when x is -2, we're just going to go 5, 1.03 to the -2 power. And then we're going to go 5, and 1.03 to the third power. We're just going to put those two things in our calculator. Okay? Those of you that weren't here, if the number that's being raised to the power is bigger than 1, like number 1, like number 3, and number 5, those are all growth problems. And if the number is between 0 and 1, like 1/2 and 0.8, that's a decay problem, okay? So you know what growth and decay is now, too. All right, so then I just go to my calculator, if I can get it to show up, and put 5, parenthesis, 1.03, caret, and then -2 power. So 4.7, we'll just go to tenths. And then I could go second enter. That's the same thing I just typed in. And I'm going to change that to a 3. And 5.5. Okay? That's all you got to do for those. So, going over answers to 4 and 6. Number 4A was 24 and B was 3/4 or 0.75. Number 6 is A, -3.125, and B is -1.024. Again, all we're doing is plugging in -2 and 3 in for X, just doing those two problems. All right, then we jump down to 12, 14, and 16. And you had to figure out if it was growth or decay. All right, so 2/5 less than 1, decay. 0.75 less than 1, decay. 1.8 bigger than 1, growth. Then you just put in your calculator. Okay? And the decay ones all basically look like a ski slope. Goes straight down and then it kind of levels off. Or like a big old, one of those water slides that you go straight down and then it kind of flattens out right before it lets you go. All right? And then the growth ones kind of start out slow and then boom, they take off. All right? So you hit your y equals. Let's go this way this time. And just put it like it is. Parenthesis, 2 divided by 5. And then caret x. And then I'll hit zoom 6 so it looks like the normal. And there you go. All right. If we do 0.75, which is 3/4, right? So if I just change that to 3/4 and graph, looks pretty close. Well, it's a little flatter, I guess. Okay. And then 1.8. 1.8. It'll start out flat and then take off. And those three will never touch the y-axis. It looks like it does, but it actually never does. That's called an asymptote. We talked about that earlier this year. A line that the graph approaches but gets really, really close to but never actually touches is called an asymptote. So the asymptote would be the x-axis. If we talked about domain and range for both of these, all three of these, the domain is all real numbers. You can put any x value in. As far as you want to negative infinity, as far as you want to positive infinity. The range, remember, is our y values. Since it doesn't touch the x-axis, it's all values y that are greater than 0, because y equals 0 is the x-axis. If you're asked to do some domain and range stuff. Okay? And then we jumped to 19. All right? The value of a mountain bike in Y dollars is approximated by that model, where T is the number of years since the bike was purchased. So this number in parentheses, is that bigger than 1 or less than 1? Less. So is that growth or decay? Decay, right? So this is decay. All right. Identify the annual percentage increase or decrease. All right. So what we do there is we subtract it from 1. Oops, not 0.065, but 0.65. And that tells us the percent, in this case, decrease. So what percent is that? 0.35. I'm letting that help them out. Thank you. 35%. Move the decimal point 2 to the right, right? So it's a decrease of 35%. And things that cars, bikes, boats, things you buy that you play with, motorcycles, they lose their value after you get them, right? Houses, on the other hand, sometimes they'll gain their value. Okay? So estimate when the value of the bike will be $50. So this is what we did. We went in our calculator and we did y equals 200.65, and we don't have a t, we'll put x, and then we're going to put y equals 50. We're going to put those two equations in our calculator. So do that. All right, and when I hit graph, I probably won't see them because I have it at that normal 0 to 10 range all the way around. I can see my exponential decay graph, but I can't see my y equals 50 because up there is 10, right? So y equals 50 is way up here. It's a horizontal line through 50. So hit zoom out. Zoom 3. You got to hit enter. And hopefully we can see both lines, both graphs. Still can't see the 50. So I got to hit zoom out again. Zoom 3, enter. We should be able to see the horizontal line now. We hardly see the exponential one, but there we go. Okay, but barely see it, but they're crossing somewhere. Okay, we're looking for that intersection. So hit second, trace, and number 5 is for intersection, and then just hit enter 3 times. First curve, enter. Second curve, enter. Guess, enter. And this x value, 3.2, is the number of years it'll take before that $200 bike is worth $50. 50 bikes, not $50. Sorry. So we're just going to use the calculator right now. Eventually, in this chapter, we'll start learning about logarithms, and we'll be able to solve that equation without using the calculator. Okay? So that's how you do 19, 20, and 26. Number 20 is exponential growth. It's a 1% increase, and it takes about 6.2 years since the beginning of the decade. And then 26, where's my answer? There it is, was a 3%. We should look at that one, which is on here, I'm sure. All right. So this is a little different. If you look at this, All right, I'll write it bigger so you can see it. It's hard to see from where you're sitting. We don't want that to be a fraction out there. We just want it to be t out there. Okay? When you're doing a growth problem, here's the basic equation for growth problems. And for decay problems, here's the basic equation. Okay? So to find the percent, that's that R value, okay? But this isn't a T here. So what we talked about on Tuesday was taking this 4.7 and raising it to, it's kind of an extra one in there, buddy, the 1/45th power. So we do that in our calculator. Oh, let's get out of there. Sorry. So we're going to go 4.7 caret and then 1/45th to see what that number is. 1.03 we'll just go with. Okay. So now we know it's what type of problem. Well, we should have known, I guess, there, but usually we wait till we see here when it's T. That's bigger than 1, so it's a growth problem, right? And how much above 100% is that? 3%. So it's a 3% increase. And we knew it was an increase. It told us in the problem, I guess. So each minute, salmonella cells increase by 3%. All right? So those of you that weren't here, hopefully that helped a little bit. Any questions? Nothing new today. I just have a worksheet, extra practice worksheet for you. And you only have to do numbers 1 to 7, just the front. You don't even have to do number 8. We'll learn how to do number 8 tomorrow.